Hello, everyone. It's awesome to be here. Who was here at Solid Day Serbia last year? All right, so you probably already know me. I'm Marco. On the internet, I'm known as Acremius. If you met me, then you already know that I'm a really, really annoying, picky, and whatever person. The problem is that I'm half German and half Italian, so I got the worst of both. This is the avatar, for those who recognize avatars. I recognize only avatars. If I met you, I talked to you, you told me your name, but you didn't tell me your nickname, or I don't know your avatar, then I probably forgot about you. I'm sorry. That's just how my brain works. I work for a company called Rove. We are consultants, which means that we come into your company, grab your money, and run. No, we're supposed to fix your stuff, but we don't do miracles. We are, anyway, willing to help you if you want. I'm mostly working on Zen Framework and Doctrine in my free time. I should do releases like Raphael said, but nobody pays me, so I'm not gonna do that. Anyway, I'm working on Doctrine project, and we're talking about Doctrine mostly today. Is there anybody that doesn't know what Doctrine is? That seems good, okay. Anyway, I need to rehash it. We are not just the ORM. We build caching libraries, we build OGMs, we build libraries to write and read from key value stores in general. We write stuff to read and write to MongoDB and so on. So we're not just building the ORM. That is just one confusing thing that a lot of people tend to kind of blur. And we're looking for contributors. If you are here, you think that you know what you're doing or you have good experience with the ORM or tools like that, especially building and fiddling around with them, please come and talk to me. Must be prepared to take unpopular decisions. It's mostly about closing issues and saying no. It's not about merging everything. So you need to be considerate about that. So we're talking about Doctrine ORM just for the legal stuff. It's a JSR 317 Hibernate-inspired ORM. We need to mention that because we took a few ideas from them, and it's GPL, well, LGPL as far as I know, so yeah, we need to mention them. But it's still quite an awesome ORM they built out there, in my opinion. It's not the nicest tool in the world, but it gets the job done. And they know what they're doing there, in the Java world, I mean. This is Doctrine best practices, specifically, and we are going to talk mostly about when and how to use the ORM. So first of all, you need to know the enemy. When you build a new application, first thing everyone does is you install some framework, you install some ORM, you install this and that and other things, and then you start building. Okay, first of all, why did you start from the tools and not from what is actually important, like starting from the tests and speccing out stuff? The truth is that the tools are your enemy most of the time. As soon as you install something, it's not somebody else's code that you drag into your project. Now it's your problem, okay? Remember that. Every time you do a composer require, as awesome as it may sound, you are bringing more problems into your project because now that code is into your project and nobody's going to fix it for you. I mean, if you pay me, I can do that, but yeah. So, read this. This is not a UTF-8 character. This is supposed to be the documentation. I didn't at the beginning, and I paid I paid because of that. So if you really start from that, please read the documentation end to end. We're talking about a very complicated and very opinionated tool with a lot of magic behavior going on. Okay, so don't take it lightly. Knowledge is power. Not everyone agrees with it, but I think it's the case. So first of all, when is an ORM an appropriate tool? Who is using actually the ORM here? Who is not using it? Who has never used it? Okay. All right. So an ORM is a system that is suited for something called OLTP application. An OLTP application is an online transaction processing application, which means you go online on a web page and you have a transaction, which is like check out the cart, add the product to my basket, register, and stuff like that. These are tiny interactions. They're small. Okay, there's like start, do 1, 2, 3 things, commit. That's it. That is an online transaction. We're not talking about giant databases and moving data around. So, it is DDD-oriented. This is a lie, because you can't really do full DDD with the ORM, but it is meant to make it very simple for you to build stuff and then integrate it into the persistence layer. And we're talking about fast prototyping. How many use MySQL Workbench for designing your application? Don't. Okay, that is from the 70s. Stop doing that stuff. Okay? That's not how you build applications anymore. You're not supposed to build like that, at least for our LTP applications. Stop worrying so much about the database. I mean, the MongoDB guys squash database in a single object anyway. You know, everything in a single object, and it works. So stop worrying so much about schemas and stuff like that. We're talking about object-oriented first, not table first. When you think about entities, don't think about tables, period. That's not your problem anymore. So, what is it not for? This is really, really, really important, because people keep using the tool and applying it for things that it's not supposed to solve. First of all, dynamic data structures. If you are using an ORM because you want to still have an SQL database backing it, okay, and you want some constraints and stuff like that, but your data is really, really squishy and moving around, and it may change, it's an integer, it's a string, and now it's a nested JSON object, and so on, that is not a good use case for the ORM, okay? You probably don't even need an SQL database for that. Reporting. Reporting is the other type of application, which is OLAP. Okay, so that's the difference. OLTP is online transaction processing. OLAP is online analytics, pretty much. So you don't take massive amounts of records and process them through the ORM. Okay, this is not what the tool is built for. That is what SQL is for. Okay, it's an amazing language. Every hipster in the world is using it for some reason. It's been around since the 70s and whatever. Use it. There's no problem in using SQL for this stuff. And it's a query language. That's what it's designed for. It's a declarative query language. You can use other things. You can use graph languages. You can use the MongoDB MapReduce system. You can use whatever you prefer. But please don't stuff things in the ORM when you're doing analytics, okay? That's not what it's for. So, where do we start? So I told you where to not use it. Let's assume that you now have an application where you actually need to use the ORM. Where do we start? First of all, you start from the entities, of course. The entities are pretty much things inside your domain. Okay, so what you understand as things that do money, that's your domain in theory. If you don't do money with your application, that's your problem. But you shouldn't be building them in the first place, in my opinion, unless it's for charity, okay? But, so you should start from the entities, and the entities are basically things at which you assign an identifier, okay? So these objects are not just consisting of an address space in memory. They have an assigned ID, and there is only ever one of those entities per ID. And entities should work without the database. Entities represent things in your domain. You should design them first without the ORM in mind, because they are concepts that exist regardless of the tool that you're going to use to save them and load them. And the database is just a dumb save and load and save and load. Think about that. Is there any DBA here? Okay, don't kill me. Okay, so I realize this is like really unorthodox for DBAs. So you start from the entities. And then, as a trick to get the system designed well, in my opinion, at least with this kind of design, force yourself to use only file put contents, file get contents, okay, serialize and unserialize. Try designing the entire system only with these 4 operations, without SQL, without any other stuff like that, and you will kind of get it right. So, you define the database afterwards. You can let it generate, you can use migrations, you can do whatever you want, but it comes afterwards. It's like a detail. All right? Therefore, you define also the mappings after you define the entities. Start from the entities, map, generate the database. You can manually define the database, but it's your pain then. So, to design entities, this is what an entity usually looks like. Everyone agree? Who does this? It's pretty okay, right? It's PHP 7, style, return type hints, and so on. This is really painful. Getters, setters everywhere. So what we're designing here is pretty much what you would call in languages like C, this is a struct for you. Entities are not typed arrays. We're not talking about an array that you push and load from the database and then you just get and set data from it. Okay, so don't design something like this because it will cause a lot of coupling with the state of your application rather than the behavior. An entity should instead have some behavior. Since it's a thing inside your domain, it has interactions. You can delete it, you can interact with it, you can, like, for example, ban a user, you can cancel a contract, you can sign a contract, you can hire an employee, you can fire an employee. That's how it works. You don't delete an employee, okay? That doesn't work. I mean, a lot of people would like to, but that doesn't work like that. Okay, so entities have behavior. The internal state of an entity is completely irrelevant to our design. So you should first design the behavior, and afterwards you design the properties, the state that you want. So you deal with it after designing the public API. You could eventually think about it as if you were designing an interface for entities. Entities usually don't need an interface because it's that fixed thing in your domain. You're not going to change it. You're not going to have 20 versions of the same thing. So you usually don't need it, but you should design the API first. So if you design state first, instead you will have a lot of coupling with the internal state, which leads to very, very tricky situations where you start depending on flags inside your entities, and you don't know whether those flags have to be considered in all situations or not. An example is when you have an authentication system and you start having flags such as, is the user banned? Is the user active? Does the user have a password? Does the user have valid email? And so on. Instead of having all these flags and designing around the state of these flags, I have some behavior on the entity that says this user can authenticate or this user cannot authenticate. And this makes it simpler because you can add and remove flags as a detail internally. So here's a better API around this. You have a user object. The user can be banned. This is some state. We are going to ignore it for now. Has a to nickname. I prefer defining getters like this. I started doing this just to trick frameworks that do use getters and setters because they don't recognize the to syntax. But then I realized that it's actually better to do it this way because this is an actual cast. I'm casting an object to another format in this way. And then you have methods to authenticate. So here you see I'm actually passing in a service, which is this check hash, which may be password, password verify, and so on. And then I have a change pass, which actually does the hashing by passing in some kind of service that does the hashing. So this is very simplistic, but you see this entity doesn't expose any getters, setters, and it kind of keeps working that way. If you don't have any behavior like this, you don't need an ORM, okay? You probably are better off using PDO and arrays, and it's perfectly okay. Active record is also okay, but you don't need an ORM like this if you don't have this. Okay, you have to think about it. If you're building just CRUD applications, and you need to be sure of that, Please don't build everything as a CRUD application. Then you don't need an ORM at all. Okay, so now we started designing the entities. Now, to prevent relying on internal state, and especially state of related entities, we want to reduce coupling between them, between the various entities. To do that, we need to respect the law of the meter. So what happens is that this is something I see very often. So we have a user. The user has a method that allows me to check whether the user has access to a specific resource. Okay, and the resources are kept inside the role object assigned to this user. So you have a role, which is administrator, super user, generic user, whatever, in your system, and this role has access levels inside it. And then what we do is we filter all the access levels and check whether the access level can access that resource. So what we did is we implemented ACL checks inside our user, which is quite okay, but there is a subtle violation here, which is this one. You see there's like 2 arrows here. I'm jumping 2 times and getting state from the role and then looping over it. So the idea is that every entity should only know about its immediate neighbor. Does anybody not know about the law of the meter? It's fine if you don't know about it. Okay, couple hands up. There's this game that children play, which is called Chinese Whispers. So what you say is you say a word to the next person, and it's snake. Okay, you say snake to the person says it to the next person, and so on in a circle. And when it comes back to you, after 30 persons say it, you got like lion. So you put the snake in and the lion comes out. Okay, that's a bit weird. So that's what the law of the meter kind of is about. So you avoid talking to people further and further away. You just talk to your immediate neighbor and trust what he says, period. So you simplify it, and now you delegate the access control logic to the first entity in the association. I realized that what we did here, we just like delegate the method call, but from the outside, from your user object, you really want this functionality without even knowing how the role system works. You just know you have a user, and then you want to check whether you have access or not. Okay, inside it may do everything you want, but the idea is you should never go more than 1 level down. Okay, so this is, obviously, of course, it's more expressive. We now understand that there is a role system, and the role system decides that, so we don't have this logic immediately in our user object. It's much easier to test. We can just swap out the entity and other advantages that are just, you know, I mean, Raphael pretty much spoke about them. So, since we jump only 1 level and we avoid exposing state, this means that we also avoid exposing collections. So, this is fairly common. If you use the Symfony form or the framework form components, you may have done this. So basically what we do is we have a user has a list of buns, so we now record them in a collection. And then I have a getBuns method that returns a collection of the current buns on the user. And when I say bun user, which may happen in a service, in a controller, in a command handler, whatever your architecture looks like, you then fetch the user, and assuming it's returning something, you say get buns, and then you add the bun. So what happens is that you are getting the user, getting the buns. Okay, the user is still in memory, but you're not acting on it. You're acting on the buns collection. Okay, and since you're modifying this object, you're also modifying this one here. And this is what is called a spooky action at a distance. Okay, so you're having mutated state just by indirection. And this is a typical cause of bugs. Instead, what you should do is you return only immutable instances, or you keep the collections completely hidden. So what you do is you pretty much reword it like this. So you have a user object. User has a list of buns again, but instead of get buns, you now allow bunning this user. And every time you bun the user, you create a new bun, and you do it inside the entity. With the ORM specifically, you just use cascade persist in this case, but this is applied to pretty much anything, even outside ORM world, in my opinion. So then you fetch the user and you just say user ban. It's much simpler, right? Validity. Really? Does anybody validate entities? I did that. Okay, it's no shame. Like, entities are always in a valid state. In object-oriented programming, which may or may not be your thing, but in object-oriented programming, objects have two responsibilities. One is hiding state, encapsulating, that's what we call it. And the other thing is messaging to other objects. That's all you do. So they talk to each other. They don't like gossip and say, oh, that guy is like this and that guy has this information and so on. They talk to each other, they tell each other what to do, not what they are. So since an object encapsulates state, its responsibility is also to keep that state consistent. So there is no validation. Entities should always, always, always be valid. So this means that when you build an entity, all the fields should be in a valid state at all times, as long as that instance exists in memory. So if you have anything like invalid state, let's say that you have a user registration process, and the user registration process has one form, and then you load the next page, and then you have another piece of the form, and then you have another page, and then you have another piece of the form. And only when all these three forms were submitted together, you can build a user object. Okay, because before these three were submitted, your user has not enough information to be built. This is very, very typical. And what people do is they take a user object and fill it field by field until it's complete. And then they check when it's valid. This is really, really terrible for design because it makes it really hard to understand whether you are in consistent state or not. So invalid state should be pushed in a different object, which is called usually a data transfer object. So what you make is, instead of having a user object down here, you have three user form objects. Like this is form 1 object, form 2 object, and form 3 object. Okay, and then you take your user and build it from these three objects. Okay, so you take these three objects, push them to, I don't know, a session, whatever you want, which is usually a terrible idea. Don't save objects to session. But let's say that you make arrays, and then you build the user object from these three arrays. It simplifies things by a lot. This is for any temporary state, anything that is squishy, that is possibly invalid, and can lead to inconsistent state. There is a good article by Bernard Shusek, the author of the Symfony form component, about how to achieve this via something called value object. We'll see that in a second. So after you call construct, your objects must be valid. Okay, this means that there should be no interaction with the DB yet. Your object exists regardless of the DB. And all the state is consistent internally. There is a good trick to make that work. If you have 20 ways to build an object, like it comes from a form, it comes from the database, it comes from serialized state, it comes from a CSV, you use something called the named constructor, which is a public static method on your entity, or a factory, however you want to call it. Since we want to really work towards keeping the state consistent, we avoid setters. Again, something that Raphael was talking about the other day. Well, yesterday. Sorry, I'm just confused about time. But you get rid of about setters, because setters are pretty much not an interaction. You're just taking state and pushing it in. You know, it's like foie gras, which is not a nice scene to see. But okay, so now we removed setters, we have validity. Now the other thing that you need to consider when building entities is that your entity should not contain anything from a framework, from a library, from any other tool. Okay, it is fine to use libraries and tools that are pretty much only providing pure functions that are predictable, but the idea is that you should really avoid having anything from a framework inside your entities. Your domain, your money stuff, whatever produces money for you, has nothing to do with whatever the life cycle of Zen framework of Symfony or Laravel is. Your product, your model of business will exist on, assuming you don't go bankrupt, okay? So you should be able to upgrade libraries at any time or migrate from them to other things. So this is something really common. So what happens here is, this is the typical user controller in a Symfony and Zen framework application. So what you have is you have some kind of user form, and this user form binds to a new user object. Okay, so what we do is, first of all, like you see there's some problems here, like new user with no details, no username, no email, whatever. It's really, really shady here. But what happens in this case are two things. First of all, we broke the rule about validity. And the second thing that went wrong here is that in most cases, people start designing getters and setters because this thing, this user form, doesn't know how to talk to our user object if we don't define getters and setters. So we start designing our domain to please the framework instead of adapting the framework so that it pleases our domain. Okay, that's the idea. The other approach, which is a bit better, is this one. So you say some kind of persist here, and you build the user object from some kind of form. This is a bit better, but in this from form data, you still have a type hint against the form component. So this means that you still have some framework dependency inside your code. You are going to use methods from the framework there, and you'll see that in the tests. So form components pretty much break this validity concept all the time. They are pretty much terrible. Both Zen form and Symfony form are absolutely horrendous at this. And it's by design, which is kind of frightening. But I mean, this is for this use case. If you use CRUD applications, for which you should not use an ORM, in my opinion, then you should be okay. But again, use data transfer objects. So instead of taking this entity object and binding it to the form, take this step 1 user registration object and bind it to the form. Step 2 user registration form object and bind it to the form, and so on. That's what you do. So you build many DTOs, which are just squishy balls of information moving around, and you don't really care if they're valid or not, and you pass them to the entities and so on. All right, lifecycle callbacks. Who uses lifecycle callbacks in the ORM? All right, avoid them when possible. Okay, don't use them, or at least avoid using them whenever possible. A lifecycle callback is pretty much what you could call a persistence hack. So a lifecycle callback is pretty much sleep and wake up and serialize and unserialize, but for ORM-specific worlds. Okay, this is pretty much in every ORM. There's some kind of hook that you can say, when you save stuff, then do also this. When you load stuff, then do also this. This is what the lifecycle callback does. Now, what happens is that in most applications that I see, people start adding logic to these lifecycle callbacks. Now, imagine without the ORM now, you JSON encode an object, and an email gets sent out. Okay? Or you serialize an object, and a database record gets deleted. That would be weird. That would be really, really, really strange. And that is what lifecycle callbacks pretty much do. So please don't use them for business logic. If you use them for saving and loading files from a drive, for connecting two separate databases and saving data together, then it's fine, okay? You can use them. But you must be aware of their scope. Don't use them outside the scope. Now, something the DBAs will love me for, but don't use auto-increment. Auto-increment, I think everyone uses it, right? Who uses auto-increment? Okay, who doesn't use it? Okay, I see like 7 hands up. Where did all the others go? I'm fairly sure everyone here uses auto-increment, or at least some sort of serial or sequence or whatever that is. So the problem with auto-increment is your objects are entities. Well, your objects are entities in first place. As I said, an entity is an object that has an identifier. This means that as soon as I call construct, it should have an identifier. Otherwise, it's not an entity, right? This means it's not valid. So, first of all, when you have auto-increment, you are going to have blocking operations in the database, because you have a user table, an address table. Okay, so you need to insert the address, then insert a user. But if you insert 100 addresses and 100 users, and they reference each other, then you have to make this operation in order. Otherwise, you don't know which ID goes where. So, first of all, you have blocking operations. You're pretty much denying any kind of bulk insert, because you have to perform every operation one by one. You cannot really make multi-transaction requests. Well, that's a bit tricky, but basically when you send in data and you don't want to save it in the database yet, but you want to do something with it, save it and operate with it, and then later on save it again, then you can't do that because the data doesn't have an ID, so you can't really reference it in a meaningful way. And you are breaking the validity again. Your object is not working without the database. So your entity is now not independent from the database. If you go back to the beginning and you think about the use case that I told you, when you say you can only use file get contents, file put contents, serialize and unserialize, if you build your system with that, then you don't really need to think about this, because you will already have found some kind of solution to have identifiers. Okay? There is a simple solution. Solution is to use UUIDs. Who heard of UUIDs? Okay. So for those who didn't know about them, a UUID is just a very, very large number. It's a 128-bit number. At least that's what current UUIDs are. And it's a very, very random number. We're talking about something specific, which is a UUID version 4. There's a specification for it. But to give you a perspective, a UUID is so random that if you kept generating 100 UUIDs per second, in the next 100 years, you will probably have like half a collision, okay? The chance of having just one collision inside the system. Now, the chance that an asteroid hits our planet are much higher than that. So my point is, if an asteroid hits our planet, we have much bigger problems than UUIDs, okay? At least I hope so. So it's really, really, really simple to use it. You just have a constructor, you pass a UUID in, and that's it. Really, it's as simple as that. The other thing that you usually have is some sort of sorting based on auto-increment. So what people do is they try to sort records by the time they were inserted, but again, this depends on transaction start time and allocation inside the sequence, so it's not really reliable. Instead, you really, really want a date time or a timestamp with a high resolution time, and this is much better than using auto-incremental IDs. Other things that you want to avoid is derived primary keys. So you have a primary key that is like a primary key of something else. This happens a lot in ISA and HASA associations in database design. When you have a composite primary key and one of the keys is some key in another table and so on. So this is because we were taught in university, in school, whatever you went to, or whatever books you have read, that we should strive to build third normal form databases. And third normal form databases are really, really good for avoiding data duplication, saving space on drive, you know, and making updates a bit easier to handle. That's why we try to get to third normal form. But they are really a pain to deal with. So you're just really, when you use one of these, you are really normalizing because they told you to normalize, not because there's an actual business reason behind it. So whenever you have some question about how to normalize more than what is really required, you have to have some sort of business requirement behind it. Somebody has told you, yes, we need that because otherwise our system can't work with this and that. Okay, that's how it must be. If there is no strong need, then don't use this stuff. The same goes for composite primary keys. Okay? Instead of a composite primary key, very often what you can do is you just define typical single ID field, which no SQL databases kind of have as a, I would say, de facto standard. And then you just use a unique constraints on the fields that are kind of your other constraint on that. So you avoid referencing the record by some sort of calculated ID. You just give it a new ID, and that's it. Simple and easy. And again, composite primary key. Are you just normalizing, or is it making any difference for your domain? So just don't build them just because you are used to database patterns. We're talking about very different patterns from the database ones. So other things that you can improve are favoring immutable entities. Is anyone here using any sort of event sourcing system? Right? Okay. I'm not going to talk about event sourcing. There's like huge talks about it. But the idea is that you can pretty much represent every state mutation in the world, and this is a bit far-fetched, but you can represent every state mutation as just a sequence of events, of things that happen. And then you can calculate what the current state at that point in time was by looking at all the past events. So this is pretty much to have an append-only structure, which has some really strong advantages. Here's an example. So what you have is you have a private message. The private message was sent from somebody to somebody. There is a content, which is probably some text here. And then you can have a list of who read this message and when. Now what you do is you have, every time you read the message, you just push a new message read with the user and this object into the collection. So now you have this growing collection, okay, and it keeps growing only. Now this is much better than setting like a flag, such as when was it last read. And by the way, again, you need to design this because there is a business requirement. Don't build it just because I told you so. But then you have just a message read, which looks like this, has just a constructor and doesn't do anything at all. And then you can do analytics on this sort of data because you keep collecting. You know when somebody that was not authorized read this message, like an administrator read private messages sent from user to user. So immutable data is much simpler to reason about. You have much less bugs because of moving parts. It is cacheable. So you create a record in the database, it is never going to change. So your database only allows insert operations on immutable data. That simplifies a lot of things, and you can cache it forever, since it's not going to change. You can do prediction on it, so you can do projection, and you can do analytics on it, which is really useful for some domains. One good example that I take is usually that accountants, okay, so people who deal with taxes and the income of a company and so on, they don't use erasers. Okay, nobody's going to erase something. If you erase something from your bookkeeping, you're going to jail. Okay, and it's literal. Okay, that's a problem. All right. Again, you may look at event sourcing for that, but there's different talks about it. Soft deletes. Who uses soft deletes? I use them. I used to use them. And there's packages for that in Doctrine as well. So soft deletes come from the past. They come from a world where you have one single database and everything has to live in there, and moving data around is really expensive. So they are a quite broken idea. So you have to keep everything in this single storage, and everything must be restorable with a single call, single update, or whatever. So the problem is that what happens with the soft delete is that you have everything in a single database, right? And this half got deleted. Half of the database got deleted. Now you have data here, and data that points at this like deleted data, okay? So you have like half the database that is kind of like dark. You can't look into it, but there's things going into there, like references going into there. So the point is your soft deletes are breaking data integrity. So you're breaking immutability first, because you're mutating data to delete it, and you're breaking data integrity. You now have reference data that you're not really allowed to do reference, but you are allowed, and it's like a blurred line, and you don't know what to do. So, yeah, and you break validity there. So what I find usually is that a soft delete can be mapped to a very different concept. So last year in March, I was working for a client that makes huge metal building machinery. So you can think of them as, these people built factories, and every machine that they built was as big as this room. Okay, can you imagine a machine that prints metal pieces and is as big as this room? And how noisy that is? Now, what happened is that they tried to delete these machines, because when the machine was removed from production, they would, it would disappear from their database, but they want to restore it. Now, you don't really delete a machine that is as big as this building. Okay, what you do is you dismantle it and put it in a storage, piece by piece, one by one, and you also want to know which piece went to which storage facility, okay? Because these machines are going to be really expensive. If you want to reprint just a single metal piece, you don't want to redesign the entire machine and rebuild it from scratch. So instead, what you do is you have a concept of archiving. You have a concept of storing. You have a concept of dismantling. You're not deleting, okay? That's really the difference. So whenever you have a soft delete inside your system, there are two reasons for doing it. One is for logging reasons. Just use a log, okay? There's no need to keep the data in the database. If it's just for logging purposes, just use a log. And the other reason is that there is some sort of other domain concept that you still haven't really uncovered, which is similar to a delete, but not really, okay? So you try to build a system with that, and it's much clearer, much more understandable. So we rewrote all the soft deletes in this system for this client so that it actually doesn't do soft deletes, but it sets some kind of archive or put on the side flag. All right, some more ORM-specific stuff. Mapping driver choice. Who uses annotations? All right. Who uses XML? All right. Who uses YAML? All right. Okay, annotations for private packages, for your own stuff that you don't need to share with the world, that you don't need to show to everyone. Use annotations and it's fine, it's okay. It's perfectly okay because they don't really do anything until you plug in the ORM. They're comments, at least in the current PHP world. When you have public packages, then please use XML. The reason for that is that I can just crawl your package, find out all the XML files, and directly scan and see what entities are defined. And I can override your mappings, which is really important for public packages. You have defined an entity. I don't like what you did. I'm going to redefine the mappings for it. Okay? For YAML, don't use YAML. We are probably going to deprecate support for YAML in Doctrine 3.0 when that happens, okay? If you use YAML, I'll YAML you, okay? Don't use YAML. We just had so many bugs just because somebody missed the indentation or didn't remember an array key or something. Lazy or eager loading. A lot of what I see is projects, people just putting eager loading everywhere. But the point is that eager loading is pretty much useless. The idea of eager loading is that in theory, every time you load this record, you're going to get all the joins automatically done for you, and the ORM is a magic box of, I don't know, ponies vomiting rainbows, you know, and it solves all the problems for you. I mean, that would be ideal, but the ORM is really not doing that, and most of the time it gets it wrong. So don't use eager loading, because what happens most of the time is instead of doing the join, you're going to have n queries, 1 for joined result. And that is sadly because we didn't really fully implement all this stuff yet. For extra lazy, instead, you have a completely separate problem. When you map a field as an extra lazy field, you have a high risk of loading by accident a huge collection into memory, and then having memory issues or performance issues because of that. So we reach the limits of what an ORM should do. We're probably already into all-up world here. We're not about small transactions anymore. So really careful when you map anything as extra lazy. Bidirectional associations to be avoided most of the time. First of all, because there is some overhead. But second, because you're introducing a bidirectional dependency between two entities. An entity tree should be root entity and then all the entities below it. It should never point in both directions. Sometimes it can't be avoided, but that's how it is. So you should only code the associations that are strictly required for your domain to work, not more than that. If you have some complex queries that don't really come out correctly, just use either SQL, which will allow you to avoid these association problems completely, or hack some complex DQL together. But don't sacrifice the design of your domain model just because you're not able to design a query that works with your associations. Custom repositories. Well, who uses custom repositories? Who uses only the Doctrine repositories? Okay, fair enough. That's good. This thing is really something that is important. You should not extend from Doctrine's repositories. When you have my repository extends Doctrine yada yada repository something, don't do that. Because you're introducing a really hard to solve dependency to the ORM, and a repository is a specific contract inside your domain. How you find user inside your system depends on how your system is designed. It doesn't depend on how the ORM is designed. So you have this kind of class which doesn't really extend anything. It should implement an interface from your domain, and then you have really, really expressive methods about what is going on. So you have public function find users that have a monthly subscription, or with underscores, or whatever you prefer. Another approach that I like a lot, that I've been using a lot lately, is query functions. So what you do is, instead of having this, where you have this find users that have a monthly subscription, you have something like this, users that have a monthly subscription, and then this object acts as a function. You can use it anywhere, and then you have like a directory, and you see all the available operations inside your domain, one by one. And the other thing that is really nice is that when a developer sees something like this, an invoke function, usually, and it's, I mean, this is far-fetched again, they will avoid adding more methods to this repository. So this repository does one and only one thing. Repositories are services, so they contain global state because they reference a database connection and the entity manager itself, which is a pain. That's like one of the big trade-offs of using Doctrine, that everything is in this hidden shared state that is behind the scenes. But repositories are services, so anything is injected in the constructor, and you should avoid having any reliance or having them mutate or build inside other things inside your domain. Okay, just inject them in the constructor of your services. So instead of using entity manager or object manager get repository, which is typical for the MongoDB ODM and ORM, just inject them to the constructors, because this one is a service locator. For those who know what the problems with the service locator are, this will be clear immediately. Okay, so it comes with all the problems of the service locator. So inject them in the constructor instead. Other things that are quite interesting are additions that you can have. You can separate get and find methods. So what I like is separating get and find methods, as in a find method can return a null. You're trying to find something, but when I define a get, the get cannot return null. And it's really simple to implement this. So what you do is you have some repository, and then you say get best log. It must return a blog post now, so I have a return type hint. It never returns null. And then if I cannot find a record, then I throw an exception. So this means that in every layer that uses this repository, I can just ignore any kind of failure there. And when a blog post not found exception is thrown, because for some reason the blog post cannot be found or whatever, I can cast it up into a 404 error, okay, or a 500 or a 400 or whatever you have in your particular use case. So you simplify error logic by a lot. All right, let's skip on this. This is long and terrible. Transactions should be unrelated. If you have a single API call or page load or whatever you have in your application that causes a write or multiple writes in your layers, you should have entity manager clear and flush, okay, first a flush and then a clear, not the opposite, between service calls. If your interaction creates a user and then registers that user against the invoicing system inside your company, those are two different services. One is user management, which is probably some kind of CRM, and then you have invoicing. These are separate subsystems inside your company. So you should treat them as completely independent, and between them you should clear the entity manager completely. So you have different transactions for different boundaries. One transaction for the CRM system, and one transaction for the invoicing system, for example. Instead, between those boundaries, between these two systems, you only pass IDs. So you basically have the same as API calls between separate applications. These should probably be separate applications on their own, but unless you have a DevOps team dedicated to fixing problems with that, I don't suggest having that. I mean, microservices are just a hype, but in my opinion. So keep pushing back and forth IDs only. Now, a lot of people usually come back at me and say, but this means that I will have a lot of queries. And that is not the case anymore, because since Doctrine 2.5, you have a component called the second level cache, which pretty much avoids all this load and save operations all the time. So you can like really clear and reload and clear and reload, and it's going to be fast enough to use it anyway. Keep normalization under control. So don't normalize just because you want to normalize. Please think about whether it makes sense or not to normalize. Most important, keep normalization freaks under control. There is that guy in your company that says, oh my God, this database looks so ugly. Okay, this is happening all the time. I was that guy. I used to be that guy in the past. So you may or may not want to gag your DBAs. But a better solution is not to use violence, talk to them, right? Because the point is that academic and practical knowledge are very different on these things. People with strong database background think that a lot of the business problems need to be solved in the database. And if you do that, you end up with having stored procedure hell. And we've seen that a lot. And I think nobody really wants to debug that. What about performance? There's different talks about it. Not going to talk much about it. But what you need to know is which hotspots are in the ORM. If you don't know these components, you should really read the documentation about it. But basically, you want to profile these 4 components. First of all, the unit of work keeps everything in memory, so it may be a really, really huge problem for performance in your application. DQL, which is basically like optimize your queries, and that's it. Repositories, so write repositories that fit your use case. You don't need to fit everything into a single query. It's about optimization and profiling again. And the second level cache component, which is really new, and I really encourage everyone to try it out. So you profile them, and measuring is really the only way to see what has to be improved. Okay, let's recap real quick, because we're really, really late now. Domain first. Don't design with MySQL Workbench. Okay? Try not even opening it. Don't do that. If you do, fine, but then don't design with the ORM. If you mix the two, it comes out as a mess anyway. Do not normalize without the need for it. We're talking about object-oriented databases. We're not talking about databases that are object-oriented. We're talking about our object-oriented stuff that goes into a database. So in theory, this stuff actually works better on a thing like MongoDB. Okay, it is actually a thing. That's how it is. But that's because it fits your business domain better. If you normalize more than what is needed, you're just making more problems than what you're solving. Or maybe you're mixing OLTP and OLAP, which is usually happening a lot of time. Instead, consider using separate databases. You have your transactional database, where things happen inside your application, and then you push data to a separate database where you actually do analysis. So you can, oh, this is dead. So you use separate databases, because your transactional data is not your reporting data. Don't run all the queries inside your system. All right, that's all I have so far. Thank you very much. Okay, we have time for some questions.
Questions?
Yeah? Don't see anybody so far. Not even the speaker scrolling? Oh, yeah, back there.
Hello?
Sorry.
My name is Victor.
Yeah.
One question for the existing application that have the existing structure. Using ORM on the existing structure?
On data applications that have an existing database structure, you can, but I've seen only pain coming from it. Okay, so, I mean, in theory, I could tell you, you know what, the ORM is super. Use it for everything, you know, Doctrine is amazing. ORMs are actually generally terrible, but they're a compromise, because otherwise you go crazy with building all this stuff yourself and maintaining consistency at application level. So what happens is that people take old databases and think, oh, an ORM is going to solve all my problems. But it's not like that, sadly. So in my opinion, an application that tries to be fitted into an ORM from an existing database is probably something that is more fit for a rewrite there. And rewrites are a big no-no in our industry. So you may instead like try and find a slow migration path into new schema that fits the ORM better before applying the ORM to an existing schema. Does that make sense? Yeah.
Any suggestions on how to hold UUIDs in the database, how to store them?
Yeah.
And what's with the performance versus the auto increment?
Okay, so UUIDs, as I said, are just integers. So if you look at all the benchmarks that were made on the web, they're all like using chart 36, because they didn't know that a UUID is a 128-bit number. So UUIDs are usually pretty much the same as normal IDs from a performance perspective. There is some sort of segmentation inside the indexes, because they're so sparse, I would say. But you know, I would not be worried about performance unless we are talking about hundreds of millions of records. Okay, until then, you don't have any problems with using UUIDs. There is a good library, which is Ramsey UUID, and then there is Ramsey UUID Doctrine, which makes sure that you store UUIDs in an optimized format. If you store it as char 36, then you're just wasting memory, and a lot of it. Okay, so that's the point. It's like, what is it, 16 bytes. It's not a 36 4-byte per character string. So, yeah. Be very wary of the benchmarks that you see around.